Hi, welcome to video 12 of the Lathe series. This episode I'm going to be finishing the cross-slide carriage, and then I'm also going to be doing lost PLA casting to make the tooth pulley that I'll use as the main drive pulley for the lathe. Before I did that, I wanted to finish the cross-slide carriage, so I started by drilling a half-inch hole all the way through. This was unfortunately too tall for my drill press, so I actually had to use the base and support it on blocks of wood instead of using the normal table. Once I had the bit started, I switched back to drilling on the table. As the hole got deeper, I started pulling the drill bit out from time to time to make sure I cleared the chips, and I tried to add a little bit of extra cutting oil, see if I could make it not bind quite so much, and that seemed to work pretty well. The 5/8 inch bit actually went in just fine. I had to sharpen it again beforehand, but it really did a great job, and then the 3/4 inch bit really went the same exact way. As you can see, I don't have enough vertical movement in my drill press either, so halfway through the hole I have to stop, turn it off, and then raise the bed, so that way I can complete the hole. But it really isn't too bad of a process. When I'm close to getting all the way through, I put a sheet of 1/4 inch plywood underneath, that way I don't put a big scar in the table once I poke the drill bit all the way through the hole. Overall, that actually was a lot easier than I was expecting. There isn't very much play with the slots that I milled for the rail cars, so I'm trying to double check here to make sure that the ball screw is actually going to fit through the hole. Luckily it does actually fit, and I shouldn't have to do any more work on that. Just getting the ball screw nut fully seated, flat against the side of the carriage, and look at that, fits with a little bit of clearance, which is all I really need. Now I'm jumping away to start on the forge. There really wasn't any good way to remove the top of the forge, so I'm using these handles from an old jungle gym. I'm going to cut them off and weld them flat to the top so that way I can have a decent thing to grab, and I'm hoping that them being hollow and a little bit separated from the body of the forge, it'll stay relatively cool so I can actually grab them with gloves rather than needing to use some kind of wrench or other tool to pick it up. I'm not sure if it was really a good idea to weld all the way around these pipes, considering they're hollow and there's a lot of heat right here. I'm confident that my welding skills are poor enough that there's plenty of pinholes for the air to escape through though, so I guess that'll be fine. The other major issue I had with the forge top was that I didn't really have a great way of setting it down. So I grabbed these 3/8 inch rods and I just welded 2 to the side. That way when I set it down, it won't be actually flat against the ground. They'll kind of prop it up so it'll sit on the back corner of the steel and then those 2 rods. With that done, I decided I may as well just do a test burn, and I really wanted to see if I could actually melt cast iron. So I went and grabbed a old brake rotor and smashed it up with a sledgehammer and then put it inside. It's pretty hard to actually see down there, but after 20 minutes or so, we've got quite a bit more heat. I had it running at about 15 psi of propane and as much forced air as I could possibly put in there, but unfortunately it seemed like it just wasn't quite enough heat, and so the cast iron was weak, but it never actually melted. It was a good test though, and it's good to know what the forge's max capabilities are. Fun fact, I forgot to set up the little camera stand, so this is me doing my best job to be a human camera stand and hold it really still so you can see the forge slowly cooling down. It's cooled down a lot, but if you toss some sawdust in there, it still has a pretty cool effect. Now for the real purpose of getting the forge all set up was doing some lost PLA casting. This is going to be the tooth pulley. I think I introduced this in an earlier video. McMaster Cars supplies CAD files for all of their parts, so I went and 3D printed the CAD file, and now I'm going to use a mix of plaster and sand, cast into a little steel container, and I'm going to hopefully burn out this plastic and replace it with brass instead, so I can use it for the main drive pulley for my spindle. I'd seen some other people doing lost PLA casting and having some trouble with the plaster cracking when they went and poured the liquid metal in, which is why I actually used such a thick steel outer container. I don't think that it really needed to be this thick, but it was just what I had sitting around, So that part actually went really well. I went and used just those wood spacers and then drilled them out as much as possible for the sprues. After letting the mold sit for a couple of days, I decided to put it in the oven to try to get the rest of the moisture out. Turns out this was a really important step because there was actually a ton of moisture left in there even after like 3 or 4 days of it sitting there. I put it upside down to try to get some of the plastic to melt out the bottom, and even though the oven was on 300 and this was PLA plastic, I still didn't really have any kind of success with much plastic dripping out the bottom. Looking back, I really should have just kept it in the oven even for like 2 or 3 hours and just had it just bake. There was still a lot of moisture to come out, and I think that the water vapor was actually keeping the mold at around 200 degrees. I think that once the mold fully dried, that was when the plastic really started to drip out of it. I didn't know that at the time though, so I thought that my temperature was just too low. I stuck it in the forge for a while, and every couple minutes we'd take it out of the forge, check if any plastic was dripping out or if any was burning off. I had it just sitting upside down with a little plate of steel below it. The mold was still actively steaming for about the first 20 minutes in the forge. Every time I would take it out, you could actually see the steam coming off it. After about 40 minutes though, it had pretty much stopped steaming, and this was when the bulk of the plastic seemed to either melt out or burn off. And I think that was really when most of the work got done. You could actually see there, just for a second, some of the steam actually just radiating out of this thing. And that was part of what made it take so long for the forge to preheat, I think. The water vapor just kind of wicking all the heat away. The wood sprues also probably weren't the best choice. It was what I had on hand, so it was fine, but you can see that they kind of burned up, and eventually most of them would drop out. But I'm sure that they left a little bit of residue inside the mold, and probably making them out of foam or plastic or something else that would burn off more completely would have been a better call. Luckily, the mold is actually a really similar size to my crucible, so my crucible tongs actually did a great job of picking it up and moving it all around each time. When the steel started to glow red, we figured that at this point basically all the water had burned out. We left the mold sitting to the side and then put some of the brass ingots in the crucible and heated that up. The pouring tongs turned out to be a huge success for stuff like this, where it really just would have been so difficult to accurately and easily pour it in. So thank you very much, Rotary SMP and everybody else, for all the suggestions. That was really helpful. I should have done a better job of scooping the slag away, but it didn't seem like pretty much any of it actually poured out by the time that I'd filled up the mold. We left the mold to sit and start to cool. We went and put the crucible back inside the forge to get it reheated and get ready to pour a couple of ingots to just use up the last of the brass. That way I can reuse it for a project later. And if you thought these were going to be nice professional looking ingots, you were sorely mistaken. So we grabbed some cans out of the recycling and held our breath while we poured the brass in there. I don't know how bad it is to breathe in whatever that coating is. I assume it's not great, and I'd certainly rather not find out. For the meantime, we just hold our breath whenever something like this is going on and then walk away to get a breath of fresh air. Hopefully that's a good enough strategy. After the mold sat and cooled down for maybe a half an hour, went and used the hose and a hammer and a rod trying to break it all away. It was surprisingly durable trying to break through the plaster, but after just a minute or two it finally burst out of there. I was really worried that it was going to somehow still be liquid inside and we were going to ruin it when we busted it out, but it really looked pretty good. First impression, it seems like the teeth came through quite well, and I don't see any obvious places that are missing metal at least. The Sawzall was great for easily being able to remove the sprues, and those sprues will go back in the scrap pile ready for the next project. While I'm sanding away the bottoms of those sprues, you can see on the back there's some texture to it. This was the bottom face when it was inside the mold, and I think that there was actually some residue of either ash or little bits of plastic which created those little indents in the bottom of the casting. So I'm thinking that if I'd spent a little bit more time burning it out, and possibly if I used some compressed air or something to maybe blow a little bit of ash or whatever else it was out of the holes. Maybe I could have avoided that. After the sander removed the bulk of the material, I put it on the mini lathe. It seems like kind of a weird order of operations to sand and then machine, but in this case I think the belt sander can really just remove material faster than this little mini lathe can. This was when I really started to realize that I should have pressure washed it or done something else to remove the rest of the plaster and sand. I could only get about 3 good cuts out of this tool each time before I had to go and sharpen it again. It only lasted maybe 2 minutes between sharpenings, just every time it would hit a patch of plaster and sand and completely dull it out. Eventually it did start to actually take shape, and I got fully past all the plaster, so it started cutting much better and I didn't have to sharpen it so often. I decided to completely lathe the side pieces off, so that way it would just be the slots for the teeth and no walls to hold the belt from sliding off from one side to the other. I'll have to make my own walls later, but this is going to make it much easier for me to file the teeth and make sure that everything is totally lined up inside. Otherwise I'd have to get in there with a Dremel and it would have been a lot more difficult. So this ended up just making more sense, even though it is going to make a little bit more work for me. This is what one side looks like when it's completely laid down and removed the entire wall. And I'm just going to switch sides and do the same thing all over again for the other. If my casting had been a little bit higher quality, I feel like I probably could have just skipped this step and just had a working product right off the bat, even if I had to use the lathe to clean up the center hole a little bit. But I kind of want to see if I can make this one work, so I'm going to mill off the second side here and hopefully I can just get it functional without having to reprint it and cast it all over again. To be honest though, it really wouldn't be a huge loss if I do have to recast this. The printing isn't a huge amount of work, I already have the file. I think going through the lost PLA casting process a second time, it would have gone a lot smoother and I would have a much better idea of what to expect. Especially with things like just switching out the sprue material for foam from being wood before, and understanding that I need to preheat this for a lot longer to get all the water out of the plaster beforehand. I think that really would have just made this whole process so much smoother. So whether I end up redoing this part or not, I'm almost certainly going to try lost PLA casting a few more times in the future to try to get the process down a little bit more smoothly. I think there's a lot of improvements that I could make over my first attempt. The lathe did leave a pretty sizable burr on both sides, so these wire cutters actually ended up being really useful. They aren't really cutting anything, but they just get a good grip on the burr and make it pretty easy to just twist it right off the sides. I also went and took the lathe and made a couple of passes just very lightly on the tips of the teeth to try to even them all out, and it seemed like that improved things. I'm assuming that there's some tolerance here since the teeth of the tooth pulley are theoretically rubber and have a little bit of compression. If somebody more knowledgeable on this has any other info, that'd be great. I'd love to know if this is something that I really need to just redo, or if maybe this will work as is. And there it is. That's mostly what I've got so far. It's going to take a little bit more filing, but I think that could be a potentially usable tooth pulley once I put some sidewalls on it. That's about all I have for this video, so thanks so much for watching. Goodbye.